Hello and welcome to the Application Development Masterclass. So, this masterclass is powered by the Infinite Web Revolution. I will be your instructor, Nibota Ismail. So, I would like you to follow up with us as we navigate throughout this masterclass. Okay, so we are going to be starting up a very long series. Definitely, I will need you to pay so much attention. Always try to walk alongside. Please do not rush with this. Take it step by step. With every step, as you see, try to follow up. I encourage you to ask questions. I encourage you to contact me. Always available to help you out. So the aim of this is so that by the end of this masterclass, you become a full stack application developer, from the front end to the back end. Everything about development, everything about application development. So get prepared to start with all of that. So since we are introducing mobile application development beginning, um, application development, it has many fields, right? So we can develop an Android application, we can develop an iOS application, we can develop a web application. So what we are going to be looking at is developing mobile application, which entails Android and iOS. So Android and iOS. So we are going to be using Flutter basically for this. So we are going to have a long series. You're going to know more about Flutter. Now, what is a mobile application? What is a mobile application? So a mobile application is a computer program or software application designed to run on a mobile device, such as a phone, tablet, or watch. Okay, now let's analyze this better. Now, by default, computer programs, in fact, your computer, for example, like what is actually being displayed to you now, the computer basically responds to, let's say, to a user. Basically, most of the times you use a computer, you perform operations and everything, but how does the computer understand what you mean? How does it perform your request? How does it actually meet up with the requirements of its setup? Now, the system, your computer system, basically uses what we call programs, right? Programs in order to run everything. So we have programs, we have processes. Process is simply a program in execution. So what that means is, in order for you to actually instruct your computer on what to do, you must write a program. So what is a program? It's simply a set of instructions that tell your computer what to do, right? So I want my computer now, let's say I want to send a text message. What happens? I click on somewhere, I go somewhere. In fact, and all of it is automated. So what is happening behind the scenes? It's basically programs which have been written in order to meet up with these requirements. So as we said, a mobile application is simply a computer program or software application designed to run on mobile devices. Now, most of the times when we think about the concept of programming computer programs, we always limit it to desktop applications, softwares, and everything, but it now goes right on to our mobile devices. So a mobile application is simply a program specifically designed to run on your mobile device. So you have a phone, it's running there. Now, there are some terminologies I think are helpful to us to know about them. I think are very important. So first of all, we talk about an SDK. Sometimes, now you need to understand that Flutter is an SDK. Flutter is basically the tool that we are going to be using, right, for we call it cross-platform application development. So we are going to get into Flutter very soon. So right now, just checking up with the basics. Now, SDK stands for Software Development Kit. Yes, Software Development Kit. So SDK, most of the time people think that an SDK is simply like a programming language or whatsoever. I don't know, it depends on how you perceive it to be, but an SDK is a software development kit. What that means is it's a set of tools, right? Tools, it contains tools, documentation, as you see, sample codes provided by software developers to assist other developers in creating software applications for a specific platform, framework, or operating system. Now I want to code an application for a mobile device, right? So what happened, I use a software development kit. So these basically are tools that have been created by other developers that can aid your process of development, right? So basically they have so many things, libraries implemented in them. We have sample codes and all other things that were made specifically by other developers to aid your own development process. So let's look at also another terminology. Sometimes we hear what we call a web view. Now a web view is a browser bundled inside of a mobile application, producing what is called a hybrid app. Now basically at first, when we have applications, right? Now let's say you want an application that should be able to run on an Android device, an iOS device, or let's say on a website by itself. So what happens, enabling this cross-platform ability was actually a problem. So what happened, people coded applications with a web interface and embedded it inside of our mobile applications. This is now called a web view, right? So basically what happens is you're actually rendering that web application inside of your mobile application for it to be able to exist on these other devices. So that's what we basically use it. So most of the time they used to call it a hybrid app. So you know that a hybrid app now can be able to run on the website, on an Android application, on an Android phone, iOS device. The reason is because they were not actually meant for that architecture. They were meant for general purpose. So actually it's simply like a website in an application, which made it actually simple. Now using a web view allows mobile apps to be built using web technologies. Very interesting. Yes, so you write a program in HTML, JavaScript, CSS. There are so many other libraries. So what happens at the end of the day, you convert it now to a native application. You convert it to a native application by enabling what we call a web view, which you now embed. Now they are not running native in compiled machine code. They are running on a hidden web browser. Do you understand what that means? Basically, when you have an application, as you said, it's a computer program. How does a program run? It relies on your underlying system architecture or your operating system in order to actually execute its code. So what that means is, for example, we have what they call compilation, right? So your code is converted to an object file, gotten an executable code, passed on to the processor of your device, and it processes it and is able to read the instructions and execute them as per the sense of the instruction. But this one is not in that way. This one is not in that way. This one are running now on a web browser, right? So they actually run on the hidden web browser embedded inside of the application. That's something which the reason I'm highlighting it is because I think you should know about that. Yeah, you should know about that. Okay, now what is Flutter? What is Flutter? Google Flutter, that's how we call it. Now we need to understand that Flutter is not a programming language. Flutter was developed by Google themselves, right? Flutter was developed by Google. So Flutter is not a programming language. As I said, Flutter is what we call an SDK, software development kit. Now most of the times people tend to confuse Flutter for let's say people tend to confuse Flutter for what we call a programming language. So if you want to program, let's say you want to program with Python, you want to program with C++, you want to program with Java, sometimes you feel that Flutter is also one of these many programming languages which are usable. No, Flutter is an SDK. I think we have explained the meaning of SDK. So Flutter uses that for its language. So the programming language powering Flutter is that. So while using Flutter, everything you are going to be doing is using that programming language. So one thing you need to know about that programming language is that is an object-oriented programming language. We will see more about object-oriented programming language in the future. So Flutter is Google's mobile SDK or UI kit that enables developers to build native apps that run on Android and iOS. So Flutter is Google's mobile SDK. There's one thing, at first Google wanted to actually develop its operating system, so they went about, it's Fisher, right? So they went about developing Flutter to aid in that process. So Flutter is actually a Google's mobile SDK which was developed by Google, and one thing you need to know about Flutter is its high and rich UI framework. It's very good. You can develop all sorts of UI with Flutter. It's actually very good. So developers write code in a single code base that works on both platforms. High productivity. Flutter was written for high productivity, to get apps out fast. Now let's explain this. Let's explain this concept. Now we spoke about the aspect of what we call hybrid application development. Flutter actually meets the need of these technologies. Now what does this mean? Right, at first we spoke about a web view, but with Flutter you can write a single code base of application that should run on an Android device, iOS, and even web at times. So what that means is you do not need to develop an application for Android, iOS. So it is what we call cross-platform. What are the advantages of cross-platform development? Let's take a look. Now, provided you are a developer, you have actually developed an application, right? It's running, it's actually good, you've been using it. Now, there are times where we have data inconsistency, right? Data inconsistency. We have problems. In fact, most of the time when you interact with the database, it's actually we have data inconsistency, data redundancy. So there are so many things that could go wrong. Yes, so essentially the aspect of inconsistency, it could be of great disadvantages to a system. So there's very poor integrity of data. There's very poor integrity of data sometimes. Now, but I'm not saying actually it's bad, but what I'm saying is using a single code base for all of these applications enables efficiency when it comes to management. Yes, it enables efficiency when it comes to management. So you can change your code and hot reload changes without any kind of delay. Okay, so this is actually very important. I think while we are going to be looking at the development process itself, you are going to understand the meaning of the term hot reload. Now, Flutter includes the UI widgets you need. Flutter works with most IDEs. So you need to understand that Flutter works with most IDEs you can think of: Android Studio, Visual Studio. High performance. Flutter has very high performance when it comes to running and everything. So it's native in nature. It interacts with your system architecture, but sometimes also, as we said, it's cross-platform. Its native ability enables it to run codes and programs very fast. Now, Google Flutter uses its own high-performance rendering engine to draw these widgets, and they have been designed to work on all mobile platforms. Very important aspect: Google Flutter uses its own high-performance rendering engine to draw these widgets, and they have been designed to work on all mobile platforms. Now, what does this mean? Now, basically, as we said, in order for your application to actually run efficiently, since an application is simply a program, what happens? It needs to rely on your system's architecture in order to be executed, right? But Google Flutter has its own rendering engine. We call it a virtual machine inside of it. So it's actually like a virtual machine which actually renders and processes all of its requests without relying on your system's architecture, which makes it extremely fast for development. Yes, it makes it extremely fast for development. So we are going to talk more about the rendering engine. Also, these widgets are extendable. Yes, you write the application code in Google's that language, and it is compiled ahead of time into machine code for native like performance. Please let's get this concept very well. You write the application code in Google's that language, and it's compiled ahead of time into machine code for native like performance. Now, what does this mean? Now, you get to write the application in a Dart programming language, right? In a Dart programming language. It's converted now to machine code. Now, what is machine code? Machine code, because you need to understand that the way in which we write the reason I'm actually going so deep into everything is because I actually want us to have a good grounds and basis on the development process as a whole. Right now, you need to understand that when you write a program, what happens, it must be converted to machine code in order for your machine to actually execute it, in order for your operating system to actually execute the code. So what that means is you write the program in that is an object-oriented programming language, which is a high-level language. Now that has, in fact, let's say Flutter has the ability now to convert this your machine code into that code into machine code that can now be run on your native environment, that is your device, if need be. Now that introduction, let's talk more about that. That's the general purpose programming language which was created by Google in 2011. So like Java, C#, and there's a similar syntax to C. Yes, so while we'll be programming with that, you are going to see it a lot. So that is actually very good when it comes to programming with its ability to, let's say, it's almost like C. So if you know C programming language, definitely you should know that very easily, actually very easily. Yes, there are just some few modifications, few things you need to know about, but it's actually very easy. Now platforms, unlike conventional languages, that has been optimized to be deployed to run in a variety of platforms within a web browser as JavaScript, and as an interpreted application as a native application. Let's delve on this right now. When we talk about running on a web browser as JavaScript, when you write code in that, the application Flutter, it has the ability to convert this that code into JavaScript, right? This is what powers its web ability. So that's what enables you now to code web applications with that. So what that means is you can write a code in that and it can be processed to JavaScript. So actually, so you don't, you know, in order to actually develop web applications, you need to write JavaScript, right? Yes, so definitely that can convert its code to JavaScript, which is a very amazing aspect about that. Yes, so also it also functions as an interpreted application. So if you've heard about programming, I think if you know about interpreted language and compiled language, yes, so that functions as an interpreted language which now can be used for native development. This actually works with our development principles. You have a project, you have a code, it's been compiled, and definitely you have an output. So that's very interesting. So we are going to talk more about its interpreted nature in the future. Now within a web browser, this is how that runs within a web browser. That provides an SDK which provides command line tools to transpile that source code into JavaScript. Yes, so that has an inbuilt SDK, right, software development kit, which has the ability to convert the source code into JavaScript. Yes, this has been developed so efficiently that the resulting transpiled JavaScript is more efficient than its hand-coded equivalent. Okay, now very interesting. So what does this mean actually? It means that if you want to code an application with JavaScript, right, if you go ahead writing all of the JavaScript code, the possibilities of efficiency are less compared to code written in that which is converted to JavaScript. Yes, because of this, the framework is really powerful. The SDK has really been built in with all of those tools. Yes, so there's what we call that part. That part is a website, so you can visit this website. Visit this website. So this is an online environment that you can use to do your development. So let me see. So you can go to this website. That, let me connect up. Oh, the requested URL was not found on this server. Okay, so let's just look for that part. Maybe there's some. Okay, that part. So you can work with that part online, or you can download that. You can download that to your device, right? So that let's see. Okay, so this is that part. So if you notice, so this is working online, right? This is working online. So void main list string. So it's actually everything. If you can see, it's almost like C. It's almost like C, right? So let me see running this. This is just a sample code which comes alongside it. So okay, this is to run the code. So I've run the code. You can see it's drinkable, so you can see this is the console, so you can be able to use that online, right? Yes, but you can now you need to go ahead to install it on VS Code. Now the reason is going to this install it on VS Code and using, you would first of all need Flutter. It's not necessary, but in order to use that, you will need that SDK, right? That SDK sometimes which has some little complications when it comes to installation. That's why when you install Flutter automatically comes with that, right? So you can easily develop with that if you have installed Flutter. But since we have not yet installed Flutter, let's say to you, while we'll be doing that programming, you come here and do your programming, let's say a little bit. Remember, we are doing application development, working with UI and some other stuff. Yes, so I already have that running on VS Code, so I'll simply be using this. I'll not need to go on that environment. Okay, so so that SDK includes a virtual machine. I spoke to us about a virtual machine. A virtual machine is a sandbox in which code may run without directly communicating with the underlying operating system. This is a very powerful feature. As I said, by default, if applications or let's say programs want to run, they need to be converted to executable code such that they can be passed on to the processor. The processor decodes the instructions and are able to execute them. So what happens when you work with that? You do not necessarily need your system architecture. Now, if you needed an operating system to actually do it, what happens? There are certain times that you want to run code. Your system may be busy. Maybe there are so many processes running at that particular instant. So what happens? What happens when this occurs? At times the program might run slowly. So that enables that code can that code can function as an interpreted application. So basically this is like an interpreted language. Okay, so talking about let's see, an interpreted language, right? Let's talking about an interpreted language. Now you need to understand that we have an interpreted language and we have a compiled language. When you are working with an interpreted language, the source code is executed directly by an interpreter. The interpreter reads and executes the code line by line, translating each statement into machine code or byte code on the go. So what that means is you do not necessarily need to get need to compile it, get a binary file before you start executing. No, the interpreter executes the code directly by reading it line by line. It executes it directly without actually having to convert it to machine code. So the interpreter analyzes and executes the code sequentially without the need for an explicit compilation step. That's something that you should understand. Yes. So we have other examples of interpreted languages like Python, JavaScript, Ruby. There are many others. Whereas let's see, when we talk about the compiled language requires separate compilation step before execution. So the source code is first transformed into machine code. This code is always called yes, an executable file, right? Yes, it's an executable file. So the compiler analyzes the entire source code and generates an optimized executable that can be directly run on the target platform. So if you notice this, it actually needs to be compiled, getting to a certain format before now passed on to your device operating system to actually run it. But when we talk about an interpreted code, what happens? It's converted and it's executed immediately, sequentially. It does not necessarily need to pass through this step. Now, hot reloading. Now, if the developer is running the that application in the that virtual environment from the command line, the just-in-time compilation can reload the code when the underlying source code changes. Okay, now let me explain to you the magic behind just-in-time compilation. There is just-in-time compilation and there is what we call ahead-of-time compilation. Now, what is just-in-time compilation? Now, actually, it's like a mixture of compilation and interpretation. What does this mean? The system, right? Your SDK is gonna convert your source code into an intermediate code, right? It's going to convert it into an intermediate code. So now whenever you need to reload that particular code, it doesn't necessarily build the entire application, like the entire source code. It doesn't run everything, the entire source code. What happens? It simply processes only what has been changed, added now to that particular intermediate code which is already present. So now the intermediate code now can easily run. Yes, the intermediate code now can easily run. So what that means is you just need to run it one time. You just need to run it one time. So immediately it's converted into that in that particular intermediate state. It can now be compiled easily. So there's one particular aspect about this when you are going to be noticing the hot reload feature. When you are using the hot reload feature, you will notice that when you have certain massive changes to your application, it's not going to be able to hot reload. What that means is you might not see the changes. You might need to hot restart or need to rebuild your application. The reason for this is because that particular interpreted intermediate code, when it is subjected to too much changes, it cannot now, let's say, just compile it. Why? Because the changes are too much. So what happens? You need to rebuild it so that you should get a new version of that particular intermediate code. Very important. You are going to notice this when we come to development on a very high scale. Now, just-in-time compilation technique used by programming languages and virtual machines to improve the runtime performance of programs. Now let me explain now to you ahead of time compilation. So ahead of time compilation, we are working with that. What happens? Your entire source code needs to be executed, like it needs to be converted and executed, compiled every time you want to run it. So every time you want to run it, it needs to do the whole process over again. Sometimes, which makes it a little bit less fast. So for example, when you are developing with Flutter, what happens? This feature enables you to the feature of hot reload, just in time compilation, enables you to view changes you have done to your application immediately, almost instantly. So it is very good. Now, Flutter development. Now we are developing a Flutter application. Most of the time you run it in debug mode and the code is just in time compiled and interpreted. Very important, right? We have actually seen how all of this works. So the debug mode actually helps you to actually run the application on a test environment. It's like a test environment. When everything works just fine, you can now set it up on release mode. And in the debug mode, you have so many features that can help you to check errors, so many other things. Yes, so the debug mode is actually a very good environment because of its all of its helping features. So in the debug mode, you can be able to see errors, you can be able to get certain things, yes, so that maybe while your application is running on a release mode, you will not necessarily have to be facing certain issues which maybe just pop up. Yes. Now, as a native application, that code can be compiled ahead of time so that the code may be deployed as machine code. Now, remember, when we talk about just-in-time compilation, we are working with its interpreted language nature. This is mostly used for features such as hot reloading, right? But in order for us to convert the entire code into machine code, this is now most of the time. Let's say I spoke to you the first time of let's say compilation, right? Yes, when you want to actually, let's say you want to get the release version, what happens? You will need to convert this your entire source code into machine code, yes, in order for it to actually be executed. So now that uses now ahead of time compilation to actually do this. Yes, so you can now be able to run these applications as using ahead of time compilation when needed. Yes, so you just need to now understand when ahead of time compilation is needed and just in time compilation is needed. Now these are features of that core. These are built-in types, collection, and other core functionalities. This library is automatically imported into every dat program. Now we spoke about it, that SDK. It comes up with these libraries directly, right? So what that means is when you are programming with C, you need to import stuff like #include stdio.h, which is the standard library, right? So what that means is in order for you to use C efficiently, you need to connect to this library, which provides enhanced features of the application of for the particular language to do what it has to do. So here are some few of that own stuff that it also relies on. So that core, this is imported automatically with the dat SDK. So every time you want to write a dat program, you would, okay, now let me give you an example of a dat program. If I come up here, I just need to write void main print hello. That's it. That's all I need to do. Let me run the program. Hello. So you notice this print statement, all of them, I do not necessarily need to start importing some other stuff, this and this. No, that automatically imports all of them into their SDK. So it makes it very simple for you to work. Very simple for you to work. So if I want to add two numbers, I can say int x is equal to 3 and y is equal to 5. Print x plus y. Let's see what that is. This one we should have a /n in front of here. So that's it. So you can see how it functions smoothly. So that's how that works. You have that async, support asynchronous programming with classes such as future and streams. We are going to be looking at it. This is one of the most powerful aspects about that, to support asynchronous programming. We are going to see about asynchronous programming in due time. That mathematical constants and functions plus random number generator. So you can always use this when you want to perform advanced mathematical computations, right? Yes. So we have that convert, very important. This is to encode. So encoders and decoders for converting between different data representations. So let's say sometimes you have information in JSON, you may want to convert it into another format. You may have information in another format, or let's say in a map you want to convert it to JSON. JavaScript object notation, right? Yes. So JSON is actually one of the most widely used formats when it comes to information sharing over databases. So JavaScript object notation, you actually see that a lot. Now here's an example code. So I want us to do a little bit of practicals, to see about that. So let's take a look. Let's look at our example and see what this holds. How we can do this. Void main, we have print app started, new app, print app finished, class app. This is it. Okay, this is aspect about object oriented programming. So it's actually simple, right? So we are going to know more about setting other things. So if you just maybe print stuffs, print hey, hello. So you can notice all of them, they work. So this is how that works. So that's just a sample of how it works. Yes. So you can perform your additions, subtraction, your computations that you want. Define your variables. So that I think that will work smoothly. Okay, so Introduction to typing. Yes, typing. Now typing, typically computer languages have fallen into two camps. You have statically typed and dynamically typed languages. Now statically typed languages, these languages have specific variable types, and the developer compiles the code using an ahead of time compiler. The compiler typically the compiler type checking is performed before the code is run. This is an excellent way to develop software, as the compiler performs static analysis of the code as part of the compilation, alerting the developer when issues arise. Now, software typically takes longer to develop in this method, but the software developed in the manner typically works better in complex scenarios. Now, let me explain to us what is statically typed data type, right? So if you notice, the next is dynamically typed languages. Now these languages don't have specific variable types and no ahead of time compilation is performed. Dynamic type languages make the development process very quick, as the developer does not typically need to recompile the code. However, the code developed in this manner tends to lend itself to simpler scenarios as it is prone to error. Let's work on this. Now, when you do the concept of programming, let's say if you have ever done C programming before, I believe if you are learning Flutter, you must have a little basis of what programming is all about. We have the aspect called data types. That's what we call that typing, data types. Now, what are data types? It simply holds represent a way in which data can be represented, right? Yes, holds a way in which data can be represented. Now, if we talk about a string in that, what is a string in that? It simply means an array of characters, which is text, like maybe your name, email, whatsoever. That's a string, no matter how long it is. Integer is a number. Double is an integer with precision, like that start having decimal points. Integers cannot take decimal point values. We have okay, I've spoken about double. We have lists. When we talk about C uses what we call array, but here there's no array. We instead have list. So now let me explain to us now the difference now between this statically typed and dynamically typed. If I write here and I put var x is equal to 3, let me print x is equal to 3, right? Now x is equal to 5. Print x again. Okay, we have 3 and 5, right? This is that's it working. Now let me see if I say here x is equal to 23, or let me say Ismail, like this. What happens? A value of string can't be assigned to a variable of type int. Now string here has gotten its value as an integer. Sorry, x here has gotten its value as an integer upon the first declaration, right? Now look at something. If I come here and change this like to this form, hello, have you noticed the error is gone? Now what happens? You can now see that immediately the value of x no longer holds an integer, but it actually holds a string, right? So it actually holds now a string. So what is var attribute? Remember, when it comes to the aspect of programming, a variable is simply a placeholder. It's simply a placeholder from used for memory allocation. What happens? A value a variable allocates memory for a specific symbol. Let's say if I want to store 24 in my memory such that I can be able to perform different computations with it. What happens? I need to look for some way to store it. So what happens? I create a variable. Variable is simply a named memory location specifically. So remember your device, let's say your programs actually in order to actually do anything, you need access to memory, right? You need to be able to store. That's the aspect of what memory is all about. So what happens if I want to actually be able to store something? I need to be able to locate my memory, and I'm able to identify specifically this memory location, such that maybe whenever I want to perform different computation and everything, I simply reference it directly, right? No need to maybe struggle. So now when I talk about var x, what is the var attribute? The var attribute means var here is simply for a variable x equals to hello. So what happens? The value of x automatically takes the data type of the value returned, the value assigned to it on the first attempt, or let's say the first value assigned to it, it automatically gets a data type. So what that means is, if I say var x, we have not specified if it's an integer, we have not specified if it's a string or whatsoever. So what is var? Var is a dynamically typed data type. So the value now here to some extent is able to change. Now if you notice it from here, since the value now here has already changed, is already known as a string, we can no longer change it again. So this is, in fact, it's not a completely let's say dynamically typed data type. So right now if I change it to 4, it can no longer go. Have you noticed? Yes, the reason is because it has now been assigned a value of string. Now if I say int x, or let me say int y is equal to 4, is good. But if I say int y is equal to hello, you notice it's an error initially, but var x equal to hello went. Now the reason is because int here specifically is an integer, and you can never pass in an a string or any other data type to it without being an integer. So this is now what we call a statically typed data type, right? So statically you already know what it needs to take, so it enables efficient programming. It enables efficient programming, right? So while you are working Flutter and everything, when you are working with this particular statically typed data types, the moment you declare it, it becomes, there's no way you can change it. Yes. So now, for example, this one automatically tells us this is now used. Now when your program is running, remember, one of the highest things you should strive as a developer is the aspect of what we call efficiency. What does this mean? If your program takes longer to perform a specific task than normal, maybe if two people write the same program and your own program takes longer to execute than another person's own, they'll prefer the other person's own. They'll prefer your own. Okay, sorry, the other person's own. The reason is because we want what is called efficiently, perform the same task but within the shortest period of time. So when I say int y is equals to 4, immediately my program sees this. Immediately it comes to execution. What happens? The system automatically knows that this is an integer, so it does not bother now to try to decode what this is. It now can automatically allocate the resources required in order to do all of the computation, right? So it's the same. If I put var x here, what happens? It needs to take out time in order to compute now what this is before it can assign it. But here it does not need to actually do that. So if I now, there's a particular data type called dynamic. So if I say dynamic a is equal to 5, print a. Interesting. Let's see something. Okay, there's an error here. Okay, so look at something, right? It's a temp code runner file that error expected declaration but got for. Oops. Okay, let me see what that's all about. Okay, so print x is equal to 4. Okay, is that one that was disturbing? Okay, now you notice that everything is fine, right? A is 5. Now A is equal to hello. Print A. Have you seen the way that A has changed? It has now gone to hello. So what happens? This data type is not static, it is dynamic. So what that means is it can change its value at any time. It can change its value at any time. They don't have a fixed type. So we have data types like a list, we have data types like map, we have data types like map, we have data types like bool, we have data types like let's see, double. Now what is double? It's an integer. Bool is simply true or false, 1 or 0, right? A map holds what we call key value pairs. We are going to see about map very soon. A list holds simply an array of characters. So that's a basic introduction to programming with that. So that typing, okay. Static types, these are types commonly used in built data types. Okay, we have int, double, bool, string buffer, list, map, set, datetime, duration, URI, error. So these are different data types that you are going to be seeing on basis. Those are static data types. Now dynamic data types, aka untyped. So you can define untyped variables by declaring them using the var or dynamic keyword. Have you seen? So the var keyword declares a variable without specifying its type, leaving the variable as dynamic. The dynamic keyword declares a variable of the type dynamic with optional typing. So you can always change it, but for var, immediately it's initialized, it can no longer be changed. Okay, so this is an example of a code program. It's an example of a code program. Now if you run this program, this is going to display to you an error compiling JavaScript. The methods need to return a type and a var does not specify a type. Okay, now let's see what this is all about. Let's try to get this code running and exact like this. Okay, so this is the code. I want to just copy it and run it. Okay, so let's see what is happening. Yes, that's an error that has been given. Now let's try to understand what this code is. Now first of all, this is our main function. These are other functions which are out. Now first of all, they have declared a specific function here called dynamic. So we have dynamic multiply method 1. We have int a, int b, which is supposed to return a times b, right? So it's dynamic, so a times b could be anything. Now we have var multiply method 2, int a, int b, return a times b. Now the return type can't be var. Try removing the keyword var. Okay, that is what it's saying. Now why is this? If you take a So most of the times we don't understand the purpose of this error. Now let's take a look and debug what is happening. Now this is a method, this is called a function. Every function needs to result to a specific data type of return, right? It needs to return a specific data type. But var is not a data type. Var is not a data type, is dynamic, right? So what that means is it does not actually refer to a specific data type, so you cannot return it. It's different from initialization, but you cannot return var. The reason is because var is undefined at this particular point. Var is not static, so we don't actually know it is not a data type. Why? Because var can only get its value upon initialization, and the only thing that can make you now to be confused here is let's say a times b not enough to, let's say, replace it? No, the reason is because this particular one, a times b, we are not initializing it to var. No, we are simply returning it. So we are actually returning var data type, which is not possible. But if you notice it, dynamic went okay. Why? Because dynamic means anything, but var means no data type. Okay, so that's why the code did not run. Okay, so I think we are going to continue again. Okay, so I believe that particular concept has been quite understood. So type interface, often the variables types are inferred when the program runs, right? In other words, when the program runs, the runtime figures out what the variable types are based on the values they are set to. This usually works well. Okay, now what are we actually seeing here? Whenever the program wants to run, the program actually needs to now understand what variable they hold, what is their data type, and everything. So the best way you can actually save your program some time is actually to clearly specify the data type. So example, we have a void main, we have dynamic x equal to 1. If x is int, print integer. Okay, now let's look at this particular program. What is saying now: dynamic x is equal to 1. If x is int, print integer. Is this true? Let's look at. So I'll say dynamic x is equal to 1. So if this is an if statement, if x is int, print. Okay, no, not equal to, x is, we are inferring. So there is a bool, we are asking it if is. So now let's see. Okay, it has printed okay. If you now notice it has printed okay. So what does this mean? It means x is an int. So let's say if x is not int, print okay. Let me run this. Okay, that's what I need to do. Now if you notice, I've changed double x is equal to 1. Then I say if x is int, equal to them means we are equivalenting it, right? So it means if x is int, now it should print okay. But definitely we know that x is a double, right? Double is simply an integer but with precision, so it has 0.1, 0.2 without decimal. Now it actually did not print okay. Why? Because x is actually a double. Now but when we had dynamic, if you notice it, it's still printed, even though okay, let's see something. Even I say if x is not int, the reason is because x is actually an integer there, but dynamic is anything, so it will still print no matter what you do there. 1.9. So this particular one is going to give an exception. Yes, it's going to give an exception because dynamic x is equal to 1.9. Automatically, that particular 1.9 we automatically know that it's a double. Yes, so it can never be. So those are just some basic concepts. So now let's look at this particular one. Dynamic x is equal to test. If x is string, print that x plus is equal to 1. Do you see what is happening here? Now dynamic x is equal to test, right? This is actually a string, so it's going to print to you string. Now x plus is equal to 1. That's simply incrementing. It's like x is equal to x plus 1. So what that means is actually from here x is actually a string, but they come and convert it here at the end. We are just lucky that it's not a loop. It was actually a loop, then definitely we can be able to perform. Okay, now let's actually okay, no, it's not gonna work. Anyway, so we'll just see more about it. Now we have a concept called string interpolation, right? Now let's get something. Now one very useful feature of that is string interpolation. You can put the value of an expression inside a string by using the dollar expression. Now let's see something. Print okay x. Okay, let's just say the value of x is x. Let's see this thing. We want to actually print the value of x, but if you not, no. Let me just use this in this way. The value of x is x. They actually want to print the value of x. How do I do this? Because remember, your print function, the print function takes in an object, right? And in this particular case, it's actually, this is a string of data that comes within it. So the value of x is x. So what that means is, if you put x inside of here, what happens? It actually prints out x to you. It cannot actually infer to this x that we have passed here. So there's an aspect of what we call string interpolation, which enables you now to call expressions inside of a string. For example, let's say if I put now a dollar, I put now x here. Look at something. The value of x is 1.9. Why? This dollar sign gives you now the ability to reference the string you're actually talking about. In fact, not only string, the interpolation there is the ability for you to incorporate an expression inside of this here string, right? So this is supposed to be a string in total, but what happens when you use the dollar sign, you can be able to call different variables inside. So now let's see int y is equals to 4.4. Okay, double. So double y is equals to 4.4. So let's say I want now to say that the value of, so I'll just say int z here, let me just call it double, or I'll just say var z so that we should not get confused. So dynamic x should be equal to 1.9, double y should be equal to 4.4, right? var z, we have not actually given it. Now what happens? The value of z, I want z to actually be, okay, let's see, the sum of x and y is z. The value of z is, I'll put $z here. Let's see what happens. The sum of x and y is z. The value of z is null. Z has not been given a value. So now let me come and say x plus y. Let's look at something. Have you seen the value of z is 1.9 plus y? What happens? We cannot express the function as we require it to be. The reason is because this particular 1.9 is not merged alongside y. So how do we perform that? We input them in braces. So I'll say x plus y. So what is here now is what we call an expression. So I can now perform expressions, so I can now be able to perform different things inside of here, different computations and some other things. So if I now see it, the value of z is, it has given me the value. So have you seen? That's how simple it works. That's how simple it works. So it's 6.3. So that's how we work with string interpolation. So you can be able to embed other things inside of your string. Remember, if you use a $sign, the $sign is going to work only for one variable. But if you have variables that are maybe 2, 3, 4, or a specific variable whose name is very long, something that it requires maybe extensive letters and everything, always include these braces. Yes, always include these braces. Okay, so that's string interpolation. Okay. Now this is just an example. Main print. Okay, we have this aspect of what we call new lines. If you want to print a new line, simply put /n after it. It's going to print a new line. Now void main double price $. Okay, now let's look at object-oriented programming. Object-oriented programming is a very important feature when it comes to that, right? Which I think you should really know of. Object-oriented programming. Okay, now let's enter the concept of what we call object-oriented programming. Now, object-oriented programming is a very important aspect of programming, which the concept about object-oriented programming is actually to model real life into programming, right? So you can actually model real life entities as programs. Person, let's say student, whatever be the case, because you know actually the whole purpose of programming is your ability to incorporate real world concepts into programming, right? So you can be able to perform things. For example, you see the aspect of artificial intelligence, it's able to reason like a human. Everything should be driving towards this sort. So what is object-oriented programming? It's a programming paradigm that organizes software development, software design and development around the concept of objects. So it treats everything like an object, right? Yes. So it has some basic principles that it actually relies on. We are going to see more about this in the future. So I'll just go ahead and explain it so that while we say it should not come new to you. We have concepts and principles such as encapsulation, inheritance, polymorphism. Yes, those are a few of them. We have abstraction. So those are some of the few aspects that we are going to be looking at. So in object-oriented programming, objects are instances of classes, which are templates or blueprints that define the properties and behaviors. Behaviors of objects. Yes, so we have what we call classes. Classes actually hold properties and behaviors of objects. So what are objects? Objects represent entities or things in the real world or in the real world domain, right? So now they actually represent objects or entities in the real world. Now a class is simply a blueprint or template for creating an object. So now let's say, for example, you have a person. Now we have an object, we have a class called person. what does person entail? A person has a name, a person has legs, a person has hand, a person has a school he attends to, maybe a mobile phone and all of these things. So now the class holds all these properties and behaviors that this person can actually do. But it is not enough. What is an object? An object is what we call an instance of a class. What is an instance of a class? An instance of a class called an object has a unique identity. What is its identity? Now, the person we are talking about, I can give him a name, Nebota Ismail. That's one aspect that can categorize now that particular person. I give him maybe, let's say I give him his shoe size. I give you the hand, maybe the dress that he wears, the hand, all of those things. So what happens? I'm actually creating objects from the general class. It's like you go into an application, you want to create a profile, you want to register into the application. What happens? They ask you for your name, they ask you for your email, your phone number, and some of those other things. So what is happening? The name, email, phone number, and all of those things that are requested for are from a parent called a class. They hold a class, but in order to create an object from that class, which is your own identity, what happens? You give them those information and they collect this information now and create an object from it, specifying now your own credentials. That's why in an application, two different people can log into the same application, but they see different things. The reason is because they have different objects operating on that particular application. So two instances of the same class running, so they can actually feel as though they are two different things. That's why you enter there, you have your own name, I have my own name, yes, but it's the same. Now we have encapsulation. Encapsulation is simply the process of bundling data, which attributes and methods, into a single unit class. So what does this mean? It's the ability for you to hide information and only make it visible inside of that class. Let's take for example you are actually programming, right? You're actually programming, or let's say you are a real person. If I come to you and until you tell me your name, it is almost impossible for me to just look at you and know your name, right? If I tell you to tell me your age, it's almost impossible for me to look at you and just tell you your age. The reason is because all of these factors are abstracted to you, or let's say they're encapsulated to you. Only you know about them. Yes. So if I go about now, I take my book and I write my name there, you actually know. So now the aspect of encapsulation is you being able to hide data within that class. So you can now be able to hide the data that is found there until you explicitly give access. They are only found internally. Let's say for example, as you are a person, you have a soul, you have maybe a mind and everything, but people cannot see all of these things. They are hidden within you. So let's say for example, if you are developing an application, let's say to create a user, as I earlier said, what happens in the application? Immediately you provide all of your details. You actually let's say you do not have explicit access to all of the methods being used. You only understand this when it comes to the real world of programming. In fact, let's carry out this example so that you should know. So now we in the aspect of object-oriented programming in the, let's say that we have spoken about some few terminologies. There's also an aspect called inheritance. Inheritance enables the creation of new classes. Inheritance enables the creation of what we call new classes based on existing classes. So what happens? You can create a new class based on an existing class which already exists. That's the principle of inheritance. So what happens is like you giving birth to a child. The child holds your properties. So that's, you see, all of these aspects are real life scenarios actually being implemented as computer program. We have an aspect called polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It enables the use of single interface or method to represent different types of objects. Now let's say, for example, right, you have built an application that's supposed to register a user. The register user class, right, let's say the register user method is one method, but whenever someone calls on that method, it creates different users. Even though it is one method, it is one behavior, but what happens, it creates different users. So one method now is able to function in diverse ways, right? So it actually does something different, but it's actually one thing. So what happens is the ability for a method to actually let's say carry on the same operation but on different instances, right? Yes, so different things are actually happening. So that's why we talk about polymorphism allows objects of different classes to be treated as objects of a common superclass. Abstraction is another aspect to that you should take note of. What is abstraction? Abstraction focuses on representing essential behaviors and the behavior of objects while hiding unnecessary details. If you go to an application, you want to create a user account, what happens? They present to you a button that you can put your email, your password, and you press register. What happens after then? Now, the all-line architecture or all the code program processes that run on the background, you have no access to, but you just know that you have to create a profile or create your user account, but all of the code programs and everything are hidden from you. This is the process of abstraction. So what happens, all of those details are actually abstracted to you. They show you only what you need to see. That's why you enter inside of an application. For example, if I enter inside of an application, okay, let's say for example you are using an application where subscription is required. They say you need to subscribe to access some features. What do you think is happening? What is happening is those features are actually present there, but your application has a way of hiding them so that you cannot see them. The application has a way of hiding them such that you cannot see them. So we have what we call modules. Modules declare multiple objects within a single file, right? So you may have multiple objects within a single file. We have the constructors. Default constructor, if you do not specify a constructor, default constructor will be created for you without arguments. Now, what is a constructor? A constructor now is a property of your class that enables you to create objects from it. Yes, that's what enables you to create objects from your class. Okay, so now let me show you an example program. This is an example program. We have a class called name. It should take your first name, it should take your last name, and it should be able to return your name to you, right? It should be able to print your name to you. Now let's implement this particular aspect. Let you see. Now I'll go on to my VS Code. I'll clean out everything here. First of all, a class, we define it. So class object, I'll call it full name. I'll create class full name. Now, a class has what we call attributes, all its properties. So now it's as a human. It's as a human, right? As a human, what do you have? You have a name, you have other features and everything. So it helps you to define all of this. But now when we talk about behaviors, a human, you can move. A human you can jump, you can talk. Those are your behaviors. So it's the same thing with this one. So let's define its attributes. So I'll say string first name, string last name. Okay, that's string first name, string last name. I want to be able to get the age of the user, and I'm able to print it, or I'm able to give it to you. So now I need to actually write a function inside of here. Okay, now this is your first name and this is your last name. Now let me write a method that is actually going to now combine these two. So I'm going to say string, or let me just say yes, I'm going to say string get full name. This is a method. This is how you specify a method. It's like a function. It's like a function the same way. So now it's supposed to return a string. I'm going to return first name plus last name. That's good, right? So now if I use this particular class, the classes are the attributes that are there. Now these are the functions that are permissible with it. Here there's only one function. When we get into Flutter, you're going to see more about functions. This is just a base. Now if you notice there's an error here. If I want to run this code, let me say if I go to I call now my main function void main. I will say yes, okay, let me just say void main. Let me try to run this program. It's going to give a lot of errors saying that first name has not been defined, not initialized, last name has not been initialized. The truth is we must initialize them. So now how do we do about this? Now a class holds blueprint, so you need to have a mechanism such that you can be able to create objects from this class, maintaining its properties and attributes. What does this mean? We are going to now need what we call a constructor, which we are now going to pass to this class. That constructor is the one which is going to help us to collect this particular attribute information such that our class can get these values. So how do we do this? We call the class name full name, then you put braces like this. Now you need to now pass in the parameters that this class requires. So I'm going to now say required, or I'm going to say this dot first name, comma, I'm going to say this dot last name. So do you know what this means? What happens is whenever we want to create a new user with full name, right? We want to create a new user with full name. In fact, let me just call okay, whenever I want to create a user, I'll just call this user. I'll just call this user. Whenever I want to create a user with full name, what happens? We need the first name, we need the last name. Now the first name and the last name are going to be passed on to this function, which now the function is going to return to you the full name. So how now is this process being done? We are going to need this constructor in order to actually get the first name and the last name. How is this done? Now we need, remember, a class now becomes like a data type. Let me say it's not actually a data type, it becomes like a structure which you can now use to define your own stuff. So I'll now come and say user Ismail is equal to, now user is the class user. It's like when I want a string, I call string, then I give the variable name. So user now has become like, if you are doing C programming uses what we call structures. So if you have a structure, you can now be able to manipulate with it. So this one, we call it a class. So and as a user, so what that means, this particular variable name is supposed to return to me a user. So user should be equal to, okay, user Ismail should be equal to, I now need to look for a way now to create a user with a unique identity called for Ismail, or let me say, I'll say user one should be equal to, now I'm going to go ahead, now I'm going to call now the constructor. Look at, I'm going to call the user constructor. Have you seen this user constructor? The user is the class, but this constructor is what helps me now to actually create now the user. So now what happens? I will need to pass in the first name. I will need to pass in the last name. The first name and the last name are going to be passed now to this function to be used. Hence, I'm going to now create a user with a unique identity. So I'm going to say Nebota. I'm going to now call Ismail here. Debuter Ismail. So this is it. So what has happened, I've created the user. Now let me print something. So I'll print user one, or okay, I'll just print user one dot first name. User one dot first name. Let me print it. See something. Nebota. User one dot last name. Look at something. Ismail, have you seen? So what happens? I can now use user one and access everything found in this class user. But what happens? I have now specified his own specific attributes. So now this is the aspect of what we call object. So this is now an object of this class user. So this one has its own identity. I can now go ahead and create user 2. So I'll say user 2 is equal to, I'll call the user constructor. I'll just give it now testing name. So if I print now user 2, print, I can now print user 2 dot get full name. The get full name is a function. So if you notice, I can access now anything inside of that class. So if I do this, have you seen what has happened? It's now saying that testing name. So that is how it has printed this guy. So if you notice now, we can create multiple users using this particular class. Users with different names. That is how your information is stored in a database. So there's this one class that is able to perform everything for you. That is how your information is stored in the database. We will only come back to this when we are actually doing now Flutter development. So asynchronicity. Now this is a very important aspect, as I told you, as I said, that supports asynchronous programming. So asynchronicity is the ability to do multiple things at the same time. For example, when a modern web application needs to get data from a server, it sends out a request and waits for the result to come back. However, the application should still be able to do things in the meanwhile, like respond to user input. Now let's take, for example, you have an application, right? You are supposed to access data from a server. Let's say, for example, because most of the times your applications you use, they have what we call a database. In order to actually access your database, you need to access your back-end infrastructure, right? Which we most of the times call your server. So how do you work with this? How do you enable all of this? You need to have a secure way of communicating with your server. So what happens most of the time, let's say if you log into Facebook, immediately you log into Facebook, you will see something like it's loading. What is loading? Your information is loading. So it's actually making a request to this information from your server. So what happens? In order to actually make requests to this request from your server, your application needs to wait for some time. It needs time to actually receive this, because most of the time this process is influenced by maybe your internet speed, maybe your server response. All of those things can actually influence it. So what happens? Asynchronous programming becomes a very vital aspect of object-oriented programming, or let's say real-world application development. Now, let's say if you have an application that only waits for data to come, maybe if the data never comes, that means your application will never be able to do anything, right? That's the aspect of what we call synchronous programming. So what does synchronous programming do? Synchronous programming now, when things are running, let's say for example, this is synchronous programming now. So what happens? This happens first, this happens first, this happens first, this happens first. So if you notice it, everything is going in a sequential order. Everything is going in a sequential order. Now, okay, so we are going to look more about asynchronicity in the future. So as of now, we just need to know that we have words like the await keyword, async. So these are keywords that enable us to work specifically with asynchronous programming. Now, future Future is mostly used in asynchronous operations. What's the purpose of future? Future enables you to perform an operation which does not occur instantaneously, or the ability for your application to be able to, let's say, make requests to information which actually are not available at that particular instant. So a future starts off as an uncompleted task, then later up ends up being completed. So for example, if your application wants to communicate with the web server, what happens initially? It is uncompleted, right? So you need to first of all request for it, so there's some time lapse, and after that time lapse, specifically if everything works in your favor, definitely you'll get it. Now if your asynchronous operation is not returning any object, you will use a future, right? Invoking and handling asynchronous operations, that offers two ways of handling asynchronous code, using the future API or using the async await. Now when you're working with that, what happens if you call the particular keyword called future? What happens? Whatever you do there could be performed in the future, right? So you could make requests for resources and all of those. And also now you can use what we call async and await. This is asynchronous programming. So if you set a specific method as async, what happens? It means it is asynchronous. So you can be able to control how the different activities are taking place. Now when you use the await keyword specifies, or let's say places a command to that particular operation to wait until that particular process is done. So if you make request to an API and you use the await keyword, what is going to happen? You are going to only continue forward with your programming until that particular data is received, right? Async and await keywords. Async when an object method is called, a feature is immediately returned and the body of the method is executed later. We shall see more about this in the future while we start up with that programming. Okay, so I think today we have actually ended with the day one of this, so we are going to continue on with day two of object-oriented programming with Dart. Yes, and overall the application development masterclass. I hope you actually enjoyed it. Thank you. We'll meet again. Remember, I'm Ngota Ismail. Do not forget to like and subscribe. Also stay updated, do practicals with everything. So we'll see again.